Okay, now let's see the additive inverse in action. In this example right here, the additive inverse, I've copied over the fact that we looked at what an additive inverse was. 7 minus y times a negative 1 gives me y minus 7. Okay, so that's the additive inverse example that we just went through. And I left it up here just to remind us of how that works. So now let's say I'm given this problem. 35x minus 5xy plus 3y minus 21. And I'm looking for groupings. Well, I see the 35 and the 5 can be divided into each other, and they both have an x, so I'll do those grouped together. And the 3 and the 21 can be grouped together, so let's see what we get. So here's my grouping. And all I did was add the parentheses to group the two halves together. All right, so now what am I going to do? I'm going to say to myself, how do I factor out of this guy? I'm going to factor a 5x out of both of these guys. And when I do that, I'm left with 7 minus y right here. So 35 divided by 5 is 7. X divided by x is 1. So 7 times 1 is 7. 5xy divided by 5x gives me just y. And so that's that term. All right. And now let's factor 3 out over here. 3 out of 3y leaves me with just y. 3 out of 21 gives me a negative 7, or negative 21, negative 7. And now I notice that I have, just from my example previously, the additive inverse concept here. 7 minus y and y minus 7. So I'm going to replace 7 minus y with y minus 7 times negative 1. Okay? So let's do that. So 5x times minus 1 times y minus 7. Okay? And so now I have the exact factoring that I needed, y minus 7 and y minus 7, and I haven't changed the problem. I've just substituted another way of writing 7 minus y with this function. And now I'm going to combine this negative 1 with this 5x. So I get negative 5x times y minus 7 plus 3 times y minus 7. And now I have my factor by grouping lined up perfectly, and I can say, hey, look how this term turned out. These can be, I can use the distributive property in reverse order and say that my final factor is negative 5x plus 3 times y minus 7. And that is my final factor, my completely factored form of the original problem, 35x plus 5xy plus 3y minus 21. Okay. So let's take a review. Factor by grouping. Okay, when do you use it? Well, number one, you need to have 4 or more, 4 plus terms in your polynomial. Otherwise, grouping won't give you the reverse distributive property that we're looking for. Okay? Then, if you have that, then what do? Group terms with some kind of common factor. Okay? And finally, look for 2 common factors. In other words, the y minus 7 times the y minus 7, or look for 2 common factors, or look for additive inverse. So that you can replace one of the 2 factors of the additive inverse with the negative 1 version of it, and then you have common factors again. And that's how you factor by grouping. Okay? Saying this sometimes is a little confusing, but here's it in letters. If I have ax plus bx plus ay plus by, okay, I want to group common ax plus bx, ay plus by, and I want to group them. And then I can pull out the factor, x out of this guy, a plus b, y out of this guy, a plus b. And now once I have the common factors, I can combine the beginning and the end, a plus b, and there is, in letter form, what we're talking about, factor by grouping. Oops, bring that up like that. So explain that again. Once I've grouped with my common factors, then I can pull the x out of the first group, the y out of the second group, and I get x plus y times a plus b. Okay. All right, and the next property, or the thing that we want to talk about, is a special property called the zero property. Zero product property. And the best way to understand the zero product property is kind of to show you something. What if I have the following term, 6 times 0? Well, we all know that equals 0, right? What if I have 0 times negative 3? Well, it doesn't matter in which order, if the 0 is second or the 0 is first, my answer is still 0, right? What if I have something like this, 5 minus 5 times 0? Well, in this case, we get 0 times 0. They're both 0, but it still doesn't change. The answer is 0. And now, what if I have something like this, negative 2 times negative 3 plus 3 equals 0. Is that a true statement? Well, we know that negative 3 plus 3 is 0, so 0 times negative 2, doesn't matter what this number is, anything times 0 is 0, so that's a true statement. So what I've done is shown you a bunch of different ways of multiplying times 0, and that's what the zero product property is. It basically says that if your product of a multiplication is equal to 0, then you either have a factor of 0 or two factors of 0. Okay, so one of the two factors must be 0. At least one of the two factors must be 0. They can both be 0. But if you know the product of something is 0, then one of the two factors must be 0. Okay, so written in letter form, if a times b is equal to 0, then you either have to have a equal to 0 and or b equal to 0. So if a, b is equal to 0, then a is equal to 0, or b is equal to 0, or a is equal to 0, and b is equal to 0. And that's the zero product property. So when you have a problem, how do you use that in a problem? Well, let's say I have this, d minus 5 times 3d plus 4. And I'm told that it equals 0. So I now know that I have a product that equals 0. So I can use the zero product property to figure out what the answer is to this. And what do? I say, well, either this is 0, or this is 0, or both of them are 0. So I make this into two problems. D minus 5 equals 0, and 3d plus 4 equals 0. So I take each part and make them into 0. I then solve each part. Over here, d equals 5. And over here, subtract 4 from both sides. 3d equals negative 4. Divide by 3. Divide by 3. D equals negative 4/3. So now my answer set to this is there's two answers. 5, comma, negative 4/3. And there's my answer set. And if we check that out, if my answer is 5, if If D is equal to 5, then this guy here is equal to 0, and then my answer is 0. But if it's not equal to 5, then D must be equal to negative 4 over 3, because if I put this D to negative 4 over 3, then this is 0, and the whole answer is 0. And that is your solution set, that one of those two answers must be true. Okay, let's try that again. That was example 4, by the way. Now let's try example 5 in your book. What if I have x squared equals 7x? Okay? So there's no 0 here. So I've got to manipulate this equation to make it be 0, a 0 equation. So first thing I do is minus 7x from both sides. And on this side, I get a 0. Remember, that's what we're looking for. And on this side, well, x squared and x are not like terms, so I just write x squared minus 7x. Okay, well now I can factor an x out of both of those, x out of both terms, so x is equal to x minus 7, and it still equals 0. Now I have my 0 product property formula coming in. I set my two equations. First half of my equation is x is equal to 0. The second half of my equation is x minus 7 equals 0. And so I then solve. Obviously that one, there's no solving needing to be done. This one I add 7, x is equal to 7. And so my solution set is 0, 7. And that is the lesson.